Welcome back to Chapter 5, Ionic Bonding, Section 5C, Properties of Ionic Compounds. By the end of this video, you will be able to describe particles and forces that are present in ionic compounds, identify that ionic compounds have high melting and boiling points, and finally identify that ionic compounds conduct electricity. First, we're going to revise quickly some information about ionic compounds. We know that all ionic compounds contain charged particles, and these charged particles, they are called ions. Ions have one or more positive charges or one or more negative charges, so we can have a positive ion that carries a positive charge or a negative ion that carries a negative charge. The oppositely charged ions in ionic compounds are held together by electrostatic forces of attraction. These electrostatic forces of attraction allows the formation of ionic bonds. It is important to remember that ionic compounds contain ions, not atoms or molecules. And in ionic compounds, there are a huge number of ions that are arranged in a giant structure or lattice. As you can see here in this figure, we have ions of Na and Cl. Those in purple are the Na plus ions, and those in green are the Cl minus ions. They are packed and arranged together repeatedly, forming the giant structure or lattice. This has a regular pattern, and so ionic compounds form crystals. Now we're going to discuss the physical properties of ionic compounds. The electrostatic attraction forces between oppositely charged ions, they are strong, and a lot of energy is needed then in order to overcome these forces to separate the ions and cause the substance to melt. That's why ionic compounds have a very high melting and boiling temperatures, because we need very high temperatures in order to break down these strong electrostatic forces. This is why ionic compounds must be heated to high temperatures before they change state. They have high boiling points and high melting points. Some ions have more than one charge, such as Mg2 plus and O2 minus. Mg doesn't have only one charge, it has two positive charges, and the same for O, it has two negative charges. These highly charged ions will attract other ions more strongly than ions with one charge. More energy will be needed here also to overcome the electrostatic forces of attraction, and so the melting point will be higher. Here are some examples of melting and boiling points of some ionic compounds. Sodium bromide, NaBr, has a melting point of 747 degrees Celsius and a boiling point of 1390 degrees Celsius. Sodium chloride has a melting point 801 degrees Celsius and a boiling point of 1413 degrees Celsius. And the last one, which is magnesium oxide, it has a very high melting point, which is 2852 degrees Celsius, and a very high boiling point, which is 3600 degrees Celsius.